Hey guys, welcome back to my channel, and in today's video we are going to study controls for principles of flight. So let's begin. So we'll start with the basics for control, so it's not too much for you guys. So let's talk about primary controls. So what are the different types of primary controls we have? We have ailerons, then we have elevator, and then we have rudder. Alright, I hope it makes sense. And now let's discuss what they help you do. So aileron, they help you roll, and that's about, am I right, about the longitudinal axis. I hope I don't have to draw and explain to you what roll is, what longitudinal axis is, what ailerons are, given that we have already covered a lot of chapters that speaks about it. So then for elevator, we have pitch, and that's about lateral axis. And then we have rudder, which gives you the yaw moment, and this is about your vertical axis. Alright, so these are the three primary controls you have, the type of motion you get, and about which axis. So alright, so yeah, there's some, I'll give you one more concept. So what happens, so this is, let's say this is a control column. Alright, let's say this is a control column. So if I move it to the left, alright, what happens, I'm creating a motion that will make the aircraft roll to the left. So how does that happen? So let's say this is the aircraft from behind after it has rolled. So what happens when you roll to the left, the direction you're rolling in, that aileron comes up, and the opposite, the upgoing aileron, this comes down. So this is what a roll to the left would look like, and similarly the opposite for a roll to the right. Anyway, so let's, and then similarly when you push it backwards, all right, that means I'm going to pitch down. So when you look at your elevator, let's say this is the back of your aircraft, let's say this is your elevator, what happens, this goes down, all right, and then you get your nose down pitching movement. Similarly, if you pull it backwards toward you, this will go up, and then you'll pitch up basically. I hope that makes sense. And then for the yawing motion, over here near your legs you have your rudder, which also act as brakes on the top part. So if you push the left rudder, what happens, so let's say this is your fin. All right, let's say this is the fin of your aircraft. All right, so this will move. If you're pressing the left rudder, this will move left. All right, and then this will give you the left yaw. I hope that makes sense. So alright, let's move to the next topic, which is aerodynamic balance. Alright, so let's discuss what aerodynamic balance exactly is. So let's say when you're moving your control surfaces, let's say when you move the elevator, what's happening is that the airflow will try to resist that movement, right? So it's not going to be very free that yeah, you can move it with one finger, right? So there's going to be some resistance from the airflow. Alright, so what happens, there's this aerodynamic force that will try to control the hinge in a direction the force is acting. So let's say this is my elevator, all right, and this is my elevator. So what's happening here is, let's say if there's a force that's acting upwards, all right, so let's say this is my force, let's say this is the C, I'm sorry, let's say this is the CP, from where the force I'm giving the control column is acting, and then this is the hinge. So there's going to be a movement that is called hinge movement, that's going to be the product of the distance between your CP and the hinge line. This is going to be called hinge movement. So what you're doing, that you have to give enough movement that you can oppose this hinge movement. All right, So this, by the way, this hinge movement is also called stick force, the force you feel when you're moving the control columns. So of course, too much of it is not desired, and you need ways to reduce it. So let's discuss ways that we can reduce it. The first being insert hinge. So what happens in this is that if there's a way that I could bring this hinge, right, this hinge line backwards, so this would reduce, the arm would reduce, and indirectly the hinge movement would reduce, right? Right. I hope it makes sense. So this is done basically inside of the control column. So let's say if this is my, if this was my hinge line before, if I bring it somewhat over here, and then again this was my CP force. So let's say if it was this much before, now the arm has reduced. So my distance, since it has reduced, F into D, it has reduced. Right? It makes sense. So in a way we have reduced the hinge moment. So the second part, or the second way, is gonna be horn balance. So in the case of horn balance, what happens is, let's say this is a control surface, all right. So, and this was my hinge line, and then this is the part of the control surface, all right. So what if I, let's say there's a part of the control surface that's going forward of the hinge line. So let's say this is the hinge line, but if there's some part of the control surface that goes forward of it, so what happens is that the moment that this, so let's say this is the hinge line, and there's some force ahead of it, and there's some force, this is aft and this is ahead. So there's some force aft of it, and there's some force up ahead of it. So this force that is being created ahead of it is going to be opposite to this, since it's opposite of the hinge line, and then this would reduce your hinge moment in a way. And then the third one is going to be internal balance. So in case of internal balance, it's the same as inside hinge, but I'll just write it down. It's nothing different, same as inside hinge, but inside the wing. So basically nothing is coming out of the wing that you could see. Alright, so these were the ways how you would reduce your hinge movement. So let's discuss some other ways that you could use to reduce your hinge movement. So there's a device called tabs. So what are tabs? They are small aerofoils mounted on trailing edge of the control surface. So what they create movement that could either increase your hinge movement or reduce. So let's discuss the first tab, which is the balance tab. Alright, so let's say this is your control surface. Alright, so as per definition, what is a tab? It's a small aerofoil mounted on the trailing edge. So if this is my control surface, there's gonna be a tab over here. So in the case of a balance tab, what happens is, let's say this is the link. Alright, the pilot is gonna control your control surface. Alright, so whatever input the pilot gives, it's gonna move the control surface. So this is your control surface. So there's a link. This link, what it does is, whenever your control surface is moving, let's say it's moving up or down. In this case, let's say it's moving down, right? In this case, it has moved down. So what happens? This, due to this link, in a way, the tab over here, it will have the opposite moment. So if this is coming down, this will go up. So what this does is, it reduces. In fact, it reduces your hinge movement. I hope it makes sense. So in this case, this type of tab is reducing your hinge movement, and there's one more thing that you need to remember, that the pilot controls the control surface. So let's say for some reason, if there was a lock on your control surface, then you won't be able to move it at all, since you're controlling this and not the tab. Alright, so let's move on to the second type of tab, which is gonna be anti-balance tab. Alright, so for the anti-balance tab, what happens is, so let's say This is your control surface, and I have moved it down, and then this is your tab, the trailing edge airfoil. So in this case, again, this concept is same. The pilot is gonna move your control surface, and due to the link, this in this case, what happens due to the linkage? This is the link. This is the link, alright. So what happens due to the linkage over here? The tab is gonna move in the same direction as your airfoil, as a control surface. I'm sorry. So what happens is this is increasing our stick force. So okay, so you might be wondering why would we want to increase? So in some aircrafts where the control is not very effective, we have this to increase the stick force. So you don't want a very free movement in your control surface. So we use anti-balance tab for that. So let's talk about the next type of tab, which is servo tab. Alright, let's say this is the control surface, and let's say there's some connection like this, and let's say this is the tab. Alright, so this is the pipe input. Alright, so what's different in this type of tab is that instead of controlling your control surface, the pipe is indirectly controlling this, the tab. So what happens is, of course, yeah, so the first difference is pilot controls the tab instead of the control surface. So let's say if the tab is moved and the direction, the direction is opposite. So since it's opposite, it's gonna reduce my stick force. So let's say if this is my control column, alright. I'll just give you an example because there are a few questions in Oxford based on this type of tab. So I just wanted to visualize. So let's say this is my control surface. Now I have pulled it, I've pushed it. Let's say I push it forward. So basically I want to pitch down. So what happens is, so when I push it forward, ultimately what used to happen is this moves down, this would move up, right? The elevator moves on and then the tab moves up. But in this case, what happens? You're controlling this. So this will move up first, and then this movement will control this, and this will move down. I hope it makes sense. So what happens if you have external control locks fitted to the control surface? Then if like say you have somehow locked this, so there are locks on your control surface. So when you park the aircraft, you don't want it to move because of the wind. So if there are some locks on your control surface, the thing is your cockpit control would still be able to move left, right, up and down. And why does this happen? This is because you're controlling the tab, not the control surface. So always check your control locks when you're using servo tabs in your aircraft. And there's a disadvantage of this. There is a slight disadvantage with blue. Its effectiveness is reduced at low IS. So the next type of tab is spring tab. So basically what spring tab is, it's a modification for the previous one, which was servo tab. So let's say this is your control surface and this is your tab. So this a sort of spring over here. So what happens, let's say you are flying slow, your IS is very low. So the forces are, your aerodynamic forces are gonna be very less, right? So your spring won't get compressed since the forces are low. And this would cause your control surface and spring tab to move together, which will give you maximum effectiveness. But what happens at higher IS, or at higher IS, your forces are also going to be high, right, on your control surface, that will resist your own motion that you're giving to the control surface. So this, due to this high forces, it causes the spring to compress, and then this compression of the spring moves the direction, the spring type, it will move it in the opposite direction. So as a result, the hinge movement, stick force and control effectiveness is reduced. I hope it makes sense. So these are the type of tabs we have to study. And then let's move on to the next topic, which is power assisted controls. So the next topic is power assisted controls. So let's say you're flying a big airliner or a jet engine aircraft. So of course the controls are going to be very hard to move, and the aerodynamic forces are going to be too much that you can't use just you're forced to move it, right? So in power assisted controls, the thing is, the force you give does not control a lot of the movement. The maximum movement is controlled by the hydraulics you have. So this hydraulics is the main thing that helps you move your control surfaces. So let's talk about one more thing, that is artificial Q field unit. So what is this? So let's say you're flying a fully powered flight control, an aircraft with fully powered flight control. That means that the entire flight control is handled by hydraulics. So in that case, your stick force is going to be very negligible, right? It's going to be almost very close to zero. So to fix this, what happens? That an artificial Q field unit is fitted. So for example, you have a bob weight. So what do? They increase the stick force. They give more field to your controls. So if this fails, what happens? Your stick force becomes zero or close to zero. So you won't feel any aerodynamic force when you're moving the control, which is not a good thing. You need some type of feel, right, to know what you're actually doing with the aircraft. So let's move over to the next topic. Thing that I wanted to discuss is called reversible on irreversible controls. Alright, so what are they? So let's say you are doing a pre-flight for your Cessna 172. So what is pre-flight? When you check your aircraft before you fly it, that's called pre-flight. So when you move the elevator from outside the aircraft, so let's say you this is your elevator, right? Right? If you move it down, if you move it up, so if and of course definitely the control column, if you're moving it up and down, the control column will move forward and backward, right? So if this is happening, then you call it reversible controls. That means the controls in which aerodynamic loads from outside the cockpit controls the inside too. So this is called reversible, and the opposite would be irreversible controls. When controls in which aerodynamic loads from outside cannot move the cockpit controls inside. That will be reversible and irreversible controls. So let's move on to the next topic, which is going to be mass balance. So let's talk about flutter. What is flutter? I hope you remember. So when vibrations in an aircraft, when they match the natural frequency of it, they keep increasing, right? That could cause damage. So to prevent flutter, what we do is, so let's say, all right. So let's say this is the CG of the control surface, and this is the hinge line, all right. So if there's a way that we bring the CG forward of the hinge line, then we could reduce of reduce flutter, which is called mass balancing. So what we do is we add a sort of weight in front of the hinge. So what this does, so let's say if I add a weight like this over here, so what this does is it brings the CG forward, close or ahead of it. So and usually this type of thing is inside of it, inside of the structure, because if this is coming out, it's protruding outside, this will increase your drag, right? So we prefer putting it inside in a way that it there's no surface coming out, right? So yeah, now I hope you guys know, like I taught you in the starting part, what happens when you move your control columns. So let's just talk about lateral control, because there's a topic regarding this that is important. So lateral control, when I talk about lateral control, that means about which axis? Longitudinal. So what happens about your longitudinal axis? You roll. So when I'm talking about about longitudinal, that's roll, and that's called lateral control. So let's say this is my aircraft, all right. So if I'm rolling to the right, that means my control column, I've moved it to the right. Then what happens? Let's say this is your wing. You have your ailerons right, you're right. So the direction you're turning in, that aileron goes up, and the opposite one goes down. All right, and then this wing goes down, this wing goes up, and then you roll in that direction you have moved your control column. So similar thing would happen in the opposite direction. I hope it makes sense. Okay, so when you move your control column to the right, you're rolling to the right, right? So this is rolling. Your aircraft is moving like this, and yawing would have been when your nose, let's say this is a top view. All right, this is a top view of the aircraft. I'm sorry for the drawing, but I'll just draw it properly so you guys understand. So let's say I'll just draw a simple aircraft. Let's say this is a top view, okay? This is my aircraft state. This is my nose to the left, and this is this is the aircraft nose to the right. So what is this showing? That your aircraft is not tilting, but the nose is pointing left and right. So this is called yawing, and this is rolling. So I'm just repeating this because there are gonna be people who haven't flown, and it's hard to visualize. I get it because I cleared TechGen before I started flying, so it was hard for me to visualize. So just making sure that you guys get it. So let's say you're rolling, okay? So if you see this thing that's going up, this is gonna create. I'm sorry. This is gonna create parasite drag. Are you with me? And to be more exact, this will create form drag, if you remember. And on the other hand, this since this why is this wing going up? Because this aileron has gone down and it's creating an aerofoil type of structure, and it's increasing lift. All right, so that's why this is going up. And if it's creating lift, what is it gonna create along with it? Induced drag. Yeah, that's correct. This is also gonna create induced drag. So the thing is, this induced drag and this form drag. So the issue is the induced drag is more compared to your form drag. So what happens? So when you're rolling to the right, you have more drag on your left wing. So what happens is you're sort of, and you're also rolling to the right, but also your nose is moving to the left. Are you getting it? So this is something you don't want, right? Like you're rolling to the right, but your nose is going to the left because, or just because of this drag. So this is called secondary effect of roll. All right, or more likely, or also known as adverse aileron yaw. And also, there's one more case that when you're side slipping, what happens? One of your wing is more into the wind than the other one. So due to this, you roll and yaw in the same direction. So in the previous case, you were doing it in the opposite direction, but when you're side slipping, one of your wing is going to be more into the wind, or let's say relative airflow, due to which there's going to be more lift, and because of that, you're going to roll and yaw in the same direction. I hope it makes sense. So let's talk more about adverse aileron yaw. So definitely it's not something you want, right? So you need to fix it. So there are a few ways that you could fix it, and I'll give you a shortcut to remember it. Just remember DFR. Duffer. Just remember the DFR. So for D it's gonna be differential aileron. Alright, so let's discuss this first. So when we talked about this, the main reason why this was happening was because this drag was more than this drag, right? So let's say if there was a way that we could equalize these drags, right? So if we equalize these drags, then there would be no yawing movement, right? Because there would be no imbalance of forces. So what we do is this upgoing aileron, we make sure that it deflects more than this one, more than the downgoing aileron, we deflect it more, all right? So what happens? The drag over here is more compared to here. So in a way, this helps you fix the yawing in the opposite direction. So that's called differential ailerons. So the next for F you have frisk ailerons. So what happens? Let's say this is all right. So you have this the left wing and the right wing. So what happens in this one is that let's say okay, let's say I'm gonna cut this aerofoil okay into so, so you can see the aerofoil part. So okay, so this is my control surface, and then this is the aileron going up. So what's basically happening? So this is the up. You can. I hope you can visualize it, right? So what we do is okay. Sorry. So the leading edge of this thing, right? The upgoing aileron. We make sure that some of it is projecting into the wind. So like it's coming out of the frame and it's into the air. So what we want to do is we want to increase the parasite drag by this, right? So again, if you're increasing drag over here, then you're going to make it equal, right? And in a way, again, you're solving your issue. So the next thing, like the next way is going to be rule spoilers. So I hope you know what spoilers are. You must have seen that on the inboard section, you have spoilers over here. So if I deploy this, right, so I'm again increasing my drag on the right wing, and again it's getting fixed. So I hope that makes sense. So yeah, there are a lot of other uses of role spoilers which we'll discuss now. So let's say, so of course, so what basically role spoilers are doing, they are s- increasing your drag, right? All right. So they can be used as speed brakes, right? So or after landing, if you want to reduce your ground distances, you can use role spoilers, right? And also there's one more thing that I want you guys to remember, that when you're in a low speed flight, you use your outboard ailerons, right? You use these. But when you're at high speed, right? When you're at high speed, there's a tendency that aileron reversal might happen. So to fix that, at high speeds, we only use the inboard roll spoilers as ailerons, right? If I use it asymmetric, like if this is up, this is down, it would do the same thing as ailerons, right? So at high speed, we use roll spoilers. I hope it makes sense. So let's discuss why this actually happens. So I hope you guys remember what wing twist was. So your root angle of incidence is more than your tip angle of incidence, and since you have ailerons at the tip, right? So let's say you're rolling to the right, and let's say I'll draw the left aileron. So if you're rolling to the right, your right aileron goes up and left aileron goes down, right? So let's say, so when this is going down, of course this will create a force like this, the lift force, right? But it's also going to produce a force downward because of the angle of incidence that is less at the tip, right? But at low speeds, it's not that much to affect this. Although it will reduce the force by this by acting in the opposite direction, but it's not enough to reverse it. But what happens at high, let's say at high speeds, this force, the force because of wing twist, this is the wing twist, right? You twist the wing and you reduce angle of incidence. This force in at high speed, so this is low speed and this is high speed, right? So at high speed, the force from wing twist is so much that that's more than the force that you get from the lift that's being generated by the control surface. So due to this, the aircraft is not no longer rolling in the direction the pilot wants it to, but in the opposite direction. So that's why we use roll spoilers at high speeds. I hope that makes sense. So there's one more way by which you can reduce your adverse learn yaw, and that is by combining your primary flight control. So for example, I give you three types of combined flight controls. The first one being elevons, second one being rudder, third one being flaperons. So elevons, as the name suggests, it's ailerons, it's elevator plus ailerons, and then rudder it's rudder plus elevator, and flaperons, it's flaps plus ailerons. I hope that makes sense. And let's move to the other part, which is called trimming. So this is important because you're going to use it a lot when you fly an aircraft, especially in any type of aircraft you fly. It's going to be very common. So what does trimming do? So let's say you're flying, right, and to maintain state alignment, you have to hold the control column all the time at an angle so that it flies straight and level. So what if I do something that without holding it without holding it, I get the same result as if I'm holding it, right? That would reduce my workload, and that is something I would desire. So what is trimming? It's basically when an aircraft can maintain its attitude and speed without the pilot's input, right? So this is called trimming. So what exactly is trimming doing? It's making a stick for zero. So what happens is that you have a trim wheel inside your aircraft. So let's say, yeah, this is your trim wheel. So, and this is how the trim looks like. So let's say this is your control surface, right? And then if it's reducing, do you remember balance tab? The movement of this is going to be opposite, right? So what this does is that the trim wheel is controlling this tab over here, which is called the trim tab. So what you do is you reduce, yeah. So let's say if I move this down, I want the nose up trim, right? So what happens if I want to pitch up? My elevator it goes up and my control column it moves down, right? So that will give you nose up trim. So what this does is this thing balances out all the aerodynamic force that needs to make this movement zero. So that's how trimming works. So let's discuss about, yeah, just I want you guys to look at it. So if I move this down, I can trim up, and if I move this up, then I can move down. So you can, in a way that you can imagine. So if this is my aircraft, let's say this is my aircraft. All right. So let's say this is my aircraft. In a way, my trim tab is controlling this part. Let's imagine like when you're flying, it's hard to remember, right? So let's say this is a trim tab. If I move it up, this it means there's a the back, so with the keel surface is gonna move up. So basically this moves down. So basically you're doing nose down trim. It's easier to remember when you're flying. This is something I've learned from my instructors. Just sharing info. So let's discuss the issues you can have with your elevator trim tab. So the disadvantage you have with trim traps, it's reduced nose up, pitch, authority with forward CG. So what does this mean? Let's say this is your elevator, right? And then this is your elevator, this is your control surface, and then this is your trim tab. So let's say that the total degrees it can move, it's 10 degrees up and it's 10 degrees down, right? So the total is going to be 20 degrees. So let's assume that this aircraft has a forward CG. So when you have a forward CG, what happens? Your nose is heavy. So if your nose is heavy, you need to bring it up. So what you do, you have to give nose up trim. So if you're giving nose up trim, what happens? I hope you guys remember. If you're giving nose up, your elevator moves up, your trim tab moves down. Yeah, because this is a sort of a balance tab, right? So if you see in this case, what has happened? That let's say this the nose up, like how much nose up I could do, it has become 5 degrees, and then the nose down has become 15 degrees. Of course, the total is still 20, but how much I can go nose up has been reduced, right? It's only 5 degrees now, so it can cause issues for me. Let's say, have you guys seen when an airliner lands? Let's say this is the runway. It does not come straight in and land like this with its wheels, right? It lands like this. The main wheel is touch and the nose wheel is up. This is called flaring. This is how you protect your nose wheel. And if you want to flare your aircraft, right, you need to pitch up. But since your authority has been reduced, it's going to be hard for you to pitch to fly your aircraft. I hope that makes sense. So there's one more topic that I want to cover, that is variable incidence tailplane. So for the bigger jets and the faster jets, it's not easy for the trim tab alone to reduce the stick forces, right? Because how much could this small tab do? So in case of the bigger jets, the entire tailplane can move and change its angle of incidence, which helps you reduce your stick forces. So this was one important topic that I wanted to cover with you guys. So there's one more tab that is also called as the fixed tab, a very basic tab. So let's say this is your rudder, all right. So in your piston engine aircraft, your aircraft has a tendency to go left at high power because of the slip stream effect, right? So instead of you giving the right rudder, let's say if there was a tab which was already fixed on the ground that you can't change in the aircraft, that gives the right drawing movement that is required. So this type of tab is something that you can fix on the ground, not in the air, and it's always fixed. All right, so yeah, that brings us to the end of the chapter. I hope you guys enjoyed, and if there's any doubt, please feel free to comment down, and let's see you in the next one. Have a great day.